In this video, we are trying to understand the single letter code that is being used for representing the 20 amino acids. I thought that this story of how they reached this single letter code for amino acid becomes very interesting for students. And this story may be inspiring for them to learn the single letter code for amino acids. In the late 1960s, a scientist in the Georgetown University, Dr. Margaret Dayhoff. Margaret Dayhoff she is the pioneer in bioinformatics. So those days she was trying to look at proteins and she felt the need for a central location for people to access information about protein. So whatever sequences of the proteins were available at that time, she tried to categorize them. Then what Margaret Dayhoff felt is, it's so difficult to give even the 3-letter code of amino acids. It is becoming very lengthy. So therefore she felt the need for giving a single letter code. You see how a simple thought led to the formation of a new era in bioinformatics. Now, she looked at the names of amino acid, compared those names with the 26 alphabets of English language. And then she felt that yes, these letters, English letters, can be assigned to amino acids. So, write the list of 20 amino acids. She felt there are a number of about 6 amino acids. They have unique names, and those alphabets, the first alphabet is repeated only once. So therefore, in the first category, out of the 26 amino acids were given the first letter because they were unique. So here is the classification. Now what is written in black color? So these amino acid, if the first letter is repeated, it's not at all repeated among 20 amino acids. So therefore, these letters are given for those amino acids, single letter code. So cysteine C, histidine H, isoleucine I, methionine M, serine S, valine V. So 6 amino acids are completed. Now we are left with the 14 amino acids. Then she felt that there are some these amino acids, these 5 amino acids, what is written in red color. And there are many amino acids with starting with A. Alanine, aspartate, arginine, etc. Here also glycine, glutamic acid. So therefore, these first letter is repeated more than once among the 20 amino acids. So you cannot give the first letter. Then she applied 2 rules. The first rule is, which of these amino acids are most abundantly or repeated number of times in every protein? Or which amino acid, even when you write the names, which amino acid has the first series? For example, alanine, aspartic acid, arginine. So AL becomes the first. So those amino acids were given the first priority. So therefore, alanine is given A, glycine is given G, leucine is given L, proline is given P, threonine is given T. So 6 plus 5, 11 amino acids are given in the alphabet. We are left with 9 amino acids. Then in the third logic, so this is the first logic, this is the second logic, this is the third logic. In the third logic, what the rule which she applied is, she looked at the phonetic symbols. Phonetically, when you speak arginine, R comes very loud. So therefore, she assigned R for arginine, argin. In the case of phenylalanine, in certain European languages, phenylalanine is F. Phe comes prominent, phenylalanine. And in certain European languages, it's written with a capital F, phenylalanine. In the case of tyrosine, she used the letter Y for tyrosine. And in the case of tryptophan, as we know, it has got a 2-ring structure. So therefore, she gave the symbol W in the case of tryptophan. You see how simple logic is applied in order to give a single letter code for amino acids. Now you are left with the 5 amino acids. Out of the 5 amino acids, these 4 amino acids, they also have got some sort of a phonetic symbol where it is, there is emphasis is given, accent. So in the case of aspartic acid, that tick, so she gave the letter D in the case of aspartic acid. In the case of asparagine, she gave the letter N. Glutamic acid, so glutamic acid, as you know, it is slightly larger than aspartic acid by 1 carbon atom, and glutamic, it is given the letter E. And glutamine, in certain European language, it is pronounced glutamine, so gave the letter Q. So with that, 19 amino acids are covered. What is left now? What is left is lysine. So lysine is the letter which is close to L, and that letter is not used for any amino acid, that is given K. Lysine is given K. So this was approved in the IUPAC nomenclature in 1968 in a wonderful paper that got published in European Journal of Biochemistry, and these rules were explained. Now comes 2 new amino acids. One is pyrrolysine, another one is selenocysteine. Selenocysteine is given in the letter U, which is close to S, or with close to S is T, which is already used, so U is given. Pyrrolysine is given in the letter O. In the nomenclature which happened in 1968, these 2 letters were avoided. Why these 2 letters were avoided? Because when you write handwritten, U will look like V, O will look like Q. So therefore these 2 letters were avoided, and this is the format that is currently accepted in naming using the single letter code of amino acids. Having understood the single letter code of amino acids, let us write the sequences of a protein. So if the rule says what is on the N terminus will be on the left hand side, what is on the C terminus will be on the right hand side. So therefore we can write this is M, C, Q, K, L, again C, G, etc. So this is how we write it, which means this is the N terminus and this is the C terminus. This is the first amino acid. Now you keep numbering. This is going to be the second, third, fourth, fifth, sixth, seventh. This is how we represent the sequences of amino acid by using single letter code. In olden times, when typewriter was being used, there used to be space inserted in between letters. If there are no punctuation marks given within the structure, that means we are sure, we are accurate about the sequences that we are writing. If we put a slash at the end or at the beginning, it means we are not very sure. Though we think that glycine is at the end, but we are not very sure whether this is the end of the protein. So that is the indication of using a slash. Many times there are sequences that are undetermined. So in such cases, what do? We put a bracket. We put a bracket to show that these sequences are undetermined. There may be another undetermined sequences also. In such case, how do we write the sequences? We will write MC bracket begins Q, K equal to LC bracket closed and G. So this is how we write. And the last one, if we come to know, if we know that these sequences are, we have inferred the sequences. If we have inferred the sequences, what we do is we put a dot in between. For example, it will be MC Q dot K L dot C G. We put a dot in order to show that the sequences are inferred. So these are some of the ways by which we write the sequences of a protein by using a single letter code.